12's multiplication principle for today's video. What we want to look at here is determining the number of outcomes, okay, to count them. Now, this could be handy for things like working out how many different number plates I could have, or poke machines, or choosing an outfit, or determining how many different ways that I could order my dinner, right? Now, what happens is we want to multiply the number of outcomes at each stage together. So, if we scan back up here, we talked about flipping 3 coins. There are 2 outcomes every time you flip a coin, heads or tails. So I multiply those together. There were 3 stages, so 2 times 2 is 4, times 2 equals 8. Now, with this example we looked at back here, where we are making numbers out of those cards, there were 3 cards in the box the first time, so it's 3. When I draw the second card out, there are only 2 cards left in that box, so it's 3 times 2 equals 6. Now, if we are looking at, let's say I've got 5 shirts and 12 ties, how many outfits can I have? I've got 5 by 12 equals 60. Now, much better to calculate it like that than to try to draw a tree with 60 different branches on the end. Righto. So we multiply them together. What we need to determine though is how many outcomes there are at each stage. Here we go, number plates. Let's look at these ones that have 3 letters followed by 3 numbers. 3 letters by 3 numbers, how many possible outcomes are there? Well, for the first digit, I've got a letter. Now that gives me 26 different letters to choose from. For the second letter, it could be one of 26 again. Okay, because I can reuse them. We know that number plates sometimes reuse those things. So I've got 26 by 26 by 26. 3-digit numbers. How many digits can I choose from? 10, right? 0 through to 9. Right, there are 6 stages to that. Now, hang on a moment while I grab my calculator to work that out, because it's a big number. I'm back. You know what the number is? It is 17,576,000. There are that many different number plates that begin with 3 letters followed by 3 numbers. It's a lot. Righto. Let's say I go out to a restaurant now. There are 4 entrees, 6 mains and 3 desserts. Right, assuming I order 1 of each, I have 4 by 6 by 3 options. Now that is equal to 72 different ways that I could choose that from what doesn't appear to be a gigantic menu. 72 different meal combinations there. Righto, one more example to look at here. If we have 125 students and I need to select a captain, a vice captain and a senior prefect. Now, you can't do any of those jobs twice. Sorry, what I mean is the captain cannot also be the vice captain. So while there might be 125 choices for captain, that would mean there are only 124 people to choose from for vice captain, 123 for senior prefect. So it's 125 by 124 by 123. And you know what I'm going to say? That's a big number. And I'm going to have to press pause again while I get my calculator and work that out. Hang on. I'm back. I worked it out. It is 1,906,500. And that is a lot of ways. Okay, certainly that would be ridiculous to try to draw a tree diagram that looked like that. Right? It's only a 3-stage event, but lots of outcomes. Righto, so that's how we use the multiplication principle to count the number of outcomes. Okay, we can use this to count the number of desired outcomes or the size of the sample space, the total number of outcomes. Right, both of those things are what we need to calculate probability. Yep, righto. And that's it for this video. You might want to watch it again because it's great. Also because these are difficult concepts. So, they're here. Right, jot down some questions, ask me in class. Outstanding.